This is the second part of the video on dipole moment, or polar versus nonpolar, and molecular geometry. So I said before we were going to get some more practice on drawing Lewis dot structures, predicting the geometries. So this is it. Okay, and so go all the way back. So we have beryllium, which is here in group 2A. So we have beryllium. There's one of them. There's 2 valence electrons, so it's 2. And we have bromine, which is in group 7. There's 2 of them. It's in group 7, so that's 14, so that gives me 16 total. Beryllium is my central atom, followed by 2 bromines on either side. So I used up 4, leaving me 12. So 2, 4, 6, 8, 10, 12. Okay. Now, beryllium only sees 4. Do I need to do a double bond? I don't know what that character is. Bond. No. Be is a metal. And an exception to octet rule. Okay, so it does not need a double bond because the beryllium is a metal and an exception to the octet rule. Okay, so right now that should give me enough room. So now looking at this, okay, I have 2 outside atoms. I have 0 lone pairs. Okay, so that makes this linear. Both outside atoms are the same, so therefore this is going to be nonpolar. Okay. Now, again, in the previous videos, I suggest that you stop this or pause this and try to do the next one on your own and come back to get the answer, because practice is always a good thing. Meanwhile, I'm going to move on. Okay, I have arsenic. Arsenic is here and in group 5A. So I have arsenic. There's 1 of them. Times 5 gives me 5. I have fluorine. I have 3 of them. And fluorine is in group 7A. So times 7 gives me 21. So it gives me 26 total. Arsenic is my central atom. It's 3 fluorines around it. Okay, so I used up 6 doing that, gives me 20. And I have 2, 4, 6, 8, 10, 12, 14, 16, 18. And I have then 2 more, which is 20. So it goes there. So for molecular geometry, I have 3 outside atoms. I have 1 lone pair. And so that makes this trigonal pyramid. You notice I dropped the AL on the second one. So I call it trigonal pyramid, pyramidal, whichever one that is. All outside atoms are the same, but because of this lone pair and it's trigonal pyramid, this one is polar. Okay, so that's the answer to that one. Again, I suggest stop pausing the video and trying to do the next one on your own, and then come back for the answer. Okay. For selenium hexafluoride, here's selenium, and selenium is in group 6A. So I have selenium. There's 1 of them. Times 6 gives me 6. I have fluoride. There's 6 of them. And again, fluoride is in group 7A. So times 7. And 7 times 6 is 42. So it gives me 48 total. I draw selenium in the center. And I typically do them like this. It's 4, 5, 6. Doesn't really matter how you space them out as long as you have 6 of them. That's not SC, that's SE. There we go. All right, so I used up 8 when I did that. No, 10, sorry, 10 when I did that. So it gives me 38. And then I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. I can't count. Let me try that again. I think I got distracted. Because I can't have more than that. So let's try this again. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. No. Okay, where did I make my mistake at? 2, 4, 6, 8, 10. I only have, that's my mistake. There's only 5 fluorines here. Gotta add a fluorine. By adding a fluorine, this becomes 12, which leaves me 36. I had 30. Leaves me 6 more to go. And it goes 2, 4, 6. So sorry. All right. So even I can make mistakes, but that's how you adapt for them. You have to realize go back and look what your mistake was. I have 6 outside atoms. I have 0 lone pairs. So that makes it octahedral. Okay. And because of the fact this is octahedral with 0 lone pairs, all outside atoms are the same. This is nonpolar. Okay. And that is the end of this video. Mistakes in